Now that we've learned a little bit about lists and seen how to use them, it's important to point out that lists are not primitive types. And this is pretty obvious since we can divide those lists into smaller component parts, that is to say, its elements. So instead of being primitive types, lists are complex types called objects. We'll discuss objects in more detail later on in the course, but for now it suffices to say that in addition to holding data, lists have built-in functions called methods for operating on that data. If we have some list, for example, we can use the dot operator to access the built-in methods of lists. So just the name of our list variable, then a dot, and then the name of our method. This means go into the current list, access a method of that list, and apply it to that list itself. Now there's 4 important methods that we'll talk about here. They are append, remove, insert, and pop. So let's go through each in turn. Starting with the append method. So if we have some list, like in the image here, that's holding a bunch of strings, we can add another element onto the back of the list using the append method. So I'd say the name of my list, dot, and then append, and then whatever value I want to add to that list. And when Python encounters this method, it just adds that value to the end of that list. To see this in practice, consider the following Python steps. So if I have some list, it's filled with a bunch of names here, I can ask what's the value of names, and it's just that list as literally written. And I can say names dot append, and then add a new name. So I'll say Hodor. And if I ask what's the value of names, notice the list has changed. So we say the list is mutated, which is to say these methods, like append and the others we'll see, these mutate the list that they're called on. Notice we didn't use any assignment operator here. We didn't say assign a new list to this variable. This says go into that existing list and change what's contained within it. The next method is known as the remove method, and unsurprisingly, this removes a specific item from the list if it's there. So if I had some list and I said l.remove q, that would look through the list for some value q and remove it if it exists. Notice our lists get shorter, and everything after that item in the list, the indexes shift down by 1. So where z was at index 3, it's now at index 2, because the thing at index 2 has been removed. In Python, I could say something like names.remove Charlie. And since Charlie is in our list, directly above where I've typed it, if I ask what's the value of our list now, it's the same list, but now it's missing that one element. Note, it's an error to remove an item that isn't already in the list. If I said names.remove Zelda, for example, we get a value error, list.remove x, but x is not in the list. When using the remove method in your code, it's then important to be safe by using the in operator before removing things. So I'd say something like x equals Enos, and if x is in names, then names.remove x. And then if I ask what's the value of names, it's removed that item. But notice if I run that same code again, we don't get an error, and our list is unmodified. So it checks first and removes it if it's there. Note also, remove will only remove a single instance of that value. So if I have a list that has, let's say, names.append Alice a second time, so it has Alice in that list twice. If I then said names.remove Alice, only one of those instances has been removed, specifically the first one. So start at the beginning, looking for that value, and as soon as it finds it, it removes that value, and then it stops looking. So the second Alice is still there. The next method is the insert method. And this works like append in that it adds a new item to the list, but with insert we can specify the specific index that we would like that item to be added to. So if I said list.insert 3x, that means at index 3, insert the value x. So it shifts all the items beyond that and inserts the value at that new index. Notice the thing that was formerly at index 3 is now at index 4. The thing formerly at 4 is now at 5. Everything at that point shifts up by 1. Everything before that point does not move. And when we're done, the item that we wanted to add is stored at the index that we wanted it to be stored at. Sometimes when using the insert method, you'll have a list that's full of integers, in which case you'll say list.insert, and then you'll pass in 2 numbers. It's important to know the first number has to be an index within the allowable range of that list, and the second number can be any number because it's just the value that you're storing in that list. So whereas the append operation always adds to the end of our list, insert adds to a specific location. Returning to our demo, we could say if this is our current names list, names.insert, and at index 1, we'll put Charlie back in. And now this is our list of names, and notice it inserted it at index 1. So everything else, Dean, which was previously at index 1, is now at index 2. Everything after that all shifted down by 1, and then we added in this new element at the requested index. We can also add items to the front of the list just by saying insert at index 0. And that adds to the front of the list. And the fourth list method that we'll learn today is known as the pop method. Pop lets us remove items from our list by specifying the index that we want to remove. Whereas remove requires us to know the specific value and go looking for that value. Pop just says whatever's at this point in the list, take that out of the list. This way we can say remove the first item or the last item or the third item, whatever it happens to be. So if I said list.pop1, it goes to index 1 and removes that item. Again, everything shifts back down, but notice we didn't have to know what was at that location in order to remove it. We just said go to that spot and pop it out. Returning to our IDE, we can do some pop operations. So I could say names.pop, and notice we can also use negative indexes here. So pop at -1 removes the item from the last. Notice this has a value, unlike some of our other operations. This one said Alice was removed. And if I look at my list now, it's the original list minus the last item, because I said remove the last item. This is very useful if we want to take items out of a list and use them. So since pop also returns the removed element, we can save that element for later. So I can say something like student equals names.pop0. Now student has the value that was removed from that list, and names no longer does. We've modified our list, and we can still use those elements that we've removed. All right, to make sure we understood all of these, let's do a quick comprehension problem. So let's bring up a notepad so we can track our variable. In this case, we only have the one variable. It's called list. So let's walk through the different values of that list. So it starts off with the value 1, 3, 5, 7. Then the next line says list.append 6. So if this was our list, then the next version of this would be 1, 3, 5, 7, 6, because append always adds to the end of our list. The next line says list.remove 1. Now remember, remove means remove the value 1, not the item at index 1. So we go looking through our list and we find 1 is at index 0. So it would have been different. If we used the index, it would have removed the 3 instead. But with remove, it's always the value. So in this case, it says remove the 1, and our list now looks like 3, 5, 7, and 6. The next line says insert 0, 4. Now again, remembering which one is the index and which one is the value. It's insert ix, so the index is first and the value is second. So at index 0, we want to insert the value 4. So shifting everything out of the way, we put a 4 at the start, and then everything else is still there. The next line says list.pop3, which means pop the third item out of our list. As say the item at index 3. So 0, 1, 2, and then 3. So we remove this 7. So now our list becomes 4, 3, 5, 6. Now if we wanted, we could have saved that 7 and done something with it, because pop returns that value. This code, however, doesn't do that. It then prints out the value of the list, which is just the last line of our table here. Now there are many other list methods available. I recommend you check out the Python documentation for more. So the Python documentation, the front door at least, can be found if you go python.org. Then there's an option here for documentation. There's an option here for documentation. There's also one here. They all go to the same place. So if we click here and then Python docs, big yellow button, opens up the Python documentation. Now there's a lot of information available on the Python documentation. The sections of this documentation that will be the most useful to you when you're starting out will be the tutorial and the 2 reference sections. But they're all quite large. You can see the tutorial is quite massive, and it goes through everything in Python. So I recommend at least taking some time to look through it. There's a lot of information on the documentation, and frankly, the Python documentation is maybe not the best organized. So it's oftentimes just going to be faster to Google it. So if you make a search for something like Python docs, and then the thing you're looking for, so list methods, it brings up the Python docs page for list methods. You can, if you want, search for just the topic, so list methods in this case, but by including the words Python docs, it ensures you're getting the actual Python documentation. The documentation that's straight from the horse's mouth, so to speak. Or I guess in this case it would be the snake's mouth. Either way, it's a good idea to get used to looking at the actual documentation, as you'll be using many different references and application programming interfaces, or APIs as they're called, throughout your career as you go forwards. So we click on that, shows the data structures, and it says list, and then it mentions all the different list methods. So this is part of the tutorial page, chapter 5. And we can see append and insert and remove and pop are all there, as well as many others, like extend, which is quite useful. It takes one list and you can add all the items from another list to it. Clear to remove a list, count to count a list, sort, which we'll talk about in a future chapter, reverse, copy, all of these options. So there's many options available. One thing I'd like to point out is that square brackets here, those are not meant to be taken literally. In this context, the square brackets mean optional arguments. So we could say list.pop without any argument. In that case, it pops the very first element. Or you can include a value, and you can say which specific element or index you want to pop. Next, let's put all this information to good use by practicing with some programming tasks. Starting with a function that accepts a number n as an argument and returns a list of all the integers in the range from 0 up to but not including n. So if I say make list 5, it should give us the list 0, 1, 2, 3, and 4. Returning to VS Code, we've created a file here for testing our lists, so we'll just modify that. So down here at the bottom we'll say def make list, and that takes in some variable n. Now the purpose of this function is to initialize a brand new list with the values of 0 through n. So we know how to go through all those values and print them, for example. We just make a loop, and for each value we'd print it out. The only difference here is, at the end of all that, we want to have a list that we can hold on to and pass back to the calling program. So in this case, we'll start with a list. Call it whatever you like. I'll call mine a list. And this is an empty list to start. So I'll say initialize an empty list. Now that we have an empty list, we can iterate through all the numbers that we want and add them into the list. So we can say for I in range from 0 to n, or if we wanted, we can just say range n, because it means the same thing. Then we can say a list.append, and then the value of whatever number we're on, in this case I. So all the values from that range, if we pass in a 5, for example, 0, 1, 2, 3, 4, I takes on each one of those one time through the loop, and we'll append it to the list, adding it to the end of the list each time. So initially our list is empty, then its list was 0, then it's the list was 0, 1, and so on. Once we're done this loop, then our list is complete, and all we have to do is return it. All right, let's make sure we call our function in the main program. So we'll say print make list 5, just to print out the result of whatever this gives us. Off in our terminal, we'll say python list.py, and it runs a program. We get the list 0 through 4. We call make list 50, then we get the numbers 0 through 49. So this is a very common pattern when initializing lists. You'll have to fill them with some sort of values. If you don't have the literal values, or if it's too much to type out all of the literal values, then you'll have some programmatic way to, one at a time, append those items into an initially empty list, giving you your final result. If, for example, we wanted to append just the even numbers, we could do this exact same thing, but then say if I mod 2 equals 0. And then we're filling in just the even numbers if we wanted to do that. Now the programming task didn't say do that, so we'll leave it at the basics, but this pattern is more versatile than just this one example. This pattern is actually so common in Python that it has its own shorthand for it. If I wanted to, I could make a new list. I could say something equivalently like list equals, and then use what's known as a list comprehension. So I could say I for I in range, in this case 0 to n, and if I only wanted the even ones, I could say if I mod 2 equals 0. This is what's known as a list comprehension. They're a Python-specific way of initializing a list under a variety of circumstances. It's not part of the course, it's not going to be on any of the tests, but it's a useful thing to know when coding in Python, so I'll include it in the notes here. In general, the syntax for a list comprehension is some variable is equal to, and then in square brackets we say some output expression. So this could be I, or it could be I squared, or whatever operation you want to apply to that variable. And then we use the keyword for, and the name of our variable, in some sequence or range, and then optionally we can say if, and then some condition. So I'm going to put these in triangle brackets because this part is optional, so as to not confuse with the square brackets here. So some output expression, so this can, in this case, that's just I, but we could also say I squared, or 3 times I, or call some function with I as its input. Okay, so some output expression for variable in sequence, which is just the top of a for loop, so for I in range in this case, or for I in range here. And then if we want some extra conditions. So we only include these values if they pass this condition. So for example, if I wanted all the squares of values, I could say something like squares equals e squared for e in, and then I could just say some range like that. Some range or list or anything that can be traversed across. So to solve the previous challenge, we could use list comprehensions instead of using the append method. Either would be acceptable in the context of this course. Okay, our next programming task says, write a function that accepts a list as an argument and returns a new list, which is the reverse of that list. Noting that this is a built-in method, so if we want, we could just say list.reverse, and it would accomplish this for us, but we're going to reinvent this wheel for the sake of understanding how this wheel works. So we're going to create a function that does this manually. We're going to go through element by element, reversing our list. So as an example, we could call the function with the list 1, 2, 3, 4, and it would return the list 4, 3, 2, 1. So to think about how our design should work for this, our input is going to be in forward order, and our output needs to end in reverse order. But our output will start empty, and then each time through the loop, we'll traverse across this list, and we'll add an item. So if we add a 1 to an empty list, it's just the list with 1. That's pretty trivial. When we get to the second item, though, when we add it to the output list, notice it needs to be added in front of the previous item. So even though it comes after, since reversing, it now needs to be placed before. When we get the next item, we want to place that before the two previous items, and again, taking the next item, inserting it in front of the others. Which is to say, we'll traverse through this list, grabbing one item at a time, and inserting it at the front of our output list. That way, each item will be added in front of all the ones that were previously before it, thus reversing the list. So let's try it out. Go back to our code, we could say def reverse list that takes in some list. Now to avoid confusion, we'll call this the forward list. As our output, we're going to make a brand new list, so let's call that one backward as opposed to forward, and that one starts empty. Then we just need to traverse through our input, taking one item at a time and adding it to the front of our list. So I could say for x in forward. Notice this is a for each loop, so x is going to be one value from that list, not an index. And then if we have this value in hand, we need to put it into our backward list. So we say backward dot, and one way we could do this is append. Now if we say backward.append x, we're going to end up with the same list, right? If we take 1 from the front and add it to an empty list, now we have a list with 1. If we take 2 from our list and then we add it to the end of our list, because append always adds to the end of our list, then 2 will be behind the 1, so it'll be in the same order that it started. So using append doesn't really work here. If we keep adding to the end of the list, we'll end up back where we started. So instead, we'll try the only other method we've learned to add items into a list, and that's the insert method. Now if we want to insert items so that they show up before the previous item's at the beginning of the list, so we want to add in front of that, so we'll insert at index 0, and the value we're adding is just whatever value we're currently looking at, so the variable x here. That'll repeat, grabbing each item, adding it to the front of the list, and when it's done, we will return it. So return backward. So let's try out our code. So come down here and we'll say print reverse list from whatever backward was. So let's just make a list that's in order 2, 3, 4, 5, 6, 7. Save and run our code. And now we get 7, 6, 5, 4, 3, 2. So the list that we gave it came back in reversed order. So as always, there's many ways we could solve this problem. We could use a while loop instead of the for loop here, but that ends up being a bit more complicated. We could have, instead of counting forwards and taking each item from the front and inserting to the front to make it go in reverse, we could have used negative indexes, that is to say start counting from the last item in our input list and adding those to the back of our list. If we take the 4, and then we take the 3 and add it to the back, and then take the 2 and add it to the back, then take the 1 and add it to the back, then our list still ends up in reverse order. We can also use the built-in reverse method, which would mutate the original list to be in reverse order. There's also a really condensed way we can solve this using slices, using some syntax I didn't cover in these notes. So I could say something like return forward that takes a slice from the beginning to the end, so taking all of it, but then you can actually include a second parameter here that is the stepping, kind of like in the range function, how it steps forward by this many, and you just include -1. That way it'll step reversed through our original list and create a copy of all the items. Let's call this a Python-specific alternative. All right, our next programming challenge says write a function that accepts a list of integers as an argument and returns a list that contains only the even numbers. So given some list 1 through 6, if we call remove odds on that list, it'll return just the even. So it'll remove 1, 3, and 5, leaving us with just 2, 4, and 6. This is an operation known as filtering a list. In this case, we want to filter out all the odd numbers or filter our list to keep just the even ones. So let's dive right in. Create a new function called remove odds that takes in some list. I'll just call it L for short. Now the plan is we want to traverse across this list, and at each one we want to say, is this an even number or is it an odd number? If it's an odd number, we'll pop it out of the list so that it's not there anymore and move on with the rest. So we'll say for I in range from 0 to the len of L. So for each item or for each index in our list, if L at I, so if the specific item mod 2 is equal to 1, so if it's an odd number. If it's an odd number, we don't want it, so we'll say L.pop, and we'll pop at that same index. And when our loop is done, we'll return our given list. So let's try this out. Down in main, we'll make sure we call our function. So call print, and we'll say remove odds, and then we'll give it some list that just has a jumble of numbers. So 4, 8, 9, 2, 2, 4, 6, 1, 7, 33, and 42. Save, run our code, and we get an error. It says index error, list index out of range. So this happens on line 58 in our remove odds function. And you can see it's at the if statement in that function. So here where we say if L at I mod 2 equals 1, this index is somehow out of range. But this index gets its value from the range 0 to the len of L, which are all the valid indexes of our list. So how is it possible that our index is reaching outside of the range if the range is limited to our list? The answer is concurrent modification. Briefly, what that means is we're modifying the list at the same time we're traversing that list, and this leads to some unexpected consequences. So in this specific case, we're passing in this list that starts 4, 8, 9, etc. And that becomes L in our function, and we say for each index in that list, check the item at that index to see if it's odd. So if L at I, if I is 0, we say L at I, that means the first item, 4. We say if 4 mod 2 equals 1, in this case it doesn't, so we skip that. We go on to the next one. Now I is 1, and it says if 8 mod 2 is 1. 8 is even, so that's also false. Loops back around. Now I is 2, so this second item here is value 9. If we say if 9 mod 2 equals 1, that's true. And as a result, it says pop this item out of the list, which means this 9 disappears, and this list continues on with all of these values. Now when we iterate back through our loop, though, the next step says I gets the next value from the range. So if I was 2, because we were 0, 1, 2, it's now saying I has the value 3. Now if I say if L at 3, and I'm looking at this list, but this list no longer contains this 9, so if I remove this 9 because we popped it, what's at index 3? Well, we've skipped this one, which was previously at index 3. It's now moved to index 2, and since we've already checked index 2, we're not going to check index 2 a second time, so this value doesn't get considered. If this were an odd number, that would be a problem because it didn't get removed. In this case, it happens to work out because it was an even number. We didn't need to do anything, but we're not doing the process as we would expect. Now this alone wouldn't cause the error we're seeing because we're seeing an index error, whereas what I just described was a logic error. But imagine if this continues on. We get the next value from the range, and the next value from the range, the next value from the range. Each time we find an odd number, we shrink this list a little bit, and then we get the next value from the range. So because the range is computed at the beginning of the loop based on the original size of our list, but each time through the loop we're shrinking the size of that list, the value of I will be getting bigger and bigger while our list is getting smaller and smaller. What that means is eventually I will have a value that's too big, that's outside of the range of that list. This is what's known as concurrent modification. We're modifying the list at the same time or concurrently while we're traversing the list. And this leads to some unexpected results. As perhaps a more visual example, consider the following code. In an interactive Python, I can just say the list L equals, and we'll just give it a single value. So it's a list that contains only a single 0. It's not an empty list, it has an element, but that element is just a 0. And then I'll say for each element in my list, I'll say L.append the current element plus 1. And just so we can see what's happening, I'll also print out the value of that element. Now this is another example of concurrent modification. Because we're using the append method, which makes our list bigger every time through the loop, the for each loop, which runs until the end of that list, is not going to reach the end of that list. If I run this code, we can see it's running in an infinite loop. And we can see the number of times it's gone through that infinite loop, and it just keeps getting bigger and bigger. So this is concurrent modification. If we're modifying the size of our list inside a loop that's based on the size of that list, then the results are some unexpected behaviors. So this tells us how not to solve our problem of filtering out all of the odd numbers from a list, but how can we solve this problem? What's the solution then? So let's define another function here and see if we can't solve it properly. We'll say def remove odds2 takes in some list L. Now there are a number of ways of solving this problem, but in general, the idea is rather than modifying the list that we're traversing, we're going to make a copy somehow. I think the simplest way to do this is to create an empty list, and rather than filtering out all the bad values, we'll copy over just the good ones. So I'll say L2 starts as an empty list, then we'll traverse through our input as we did before. So for I in range from 0 to the len of our input, and then again we'll need to check if each number is even or odd. So we'll say if L at I mod 2 is equal to 0 in this case. So before we were saying if it's a bad value, remove it from our list. Now we're saying if it's a good value, in this case, we'll keep it. So we'll say L2.append L at I. So if it's a good value, we'll move that over into our result list. Now, once we've gone through all of the values in our input, checking if they're good and keeping the good ones, then all we need to say is return L2. Now notice the size of L isn't changing through this loop. Right, our range starts from 0 to the length of L, and each time through the loop it grabs one element. If it finds a good value, it copies it over, but then the next value is still just going to be the next value. We didn't modify the original list to end up skipping anything in that case. Let's save our code and try it out. So exit. Make sure we're running the right version of this function. Remove odds 2. Save our code and run. And now it doesn't crash. And looking at our list, we see only even numbers. Now, as always, there's many ways you can solve this problem, and I strongly recommend trying out to see if you can find any of the other methods yourself. But that's it for this video, where we introduce the notion that lists are more complex than primitive types. They can contain many elements, and they have built-in methods which mutate the values within that list. So we saw append, insert, remove, and pop, which in this case expand or shrink the size of our list.